fill in the blanks, add the columns, write a descriptive answer, write a proof. They will typically not be interested in all of that. Right? They will be looking at the whole system of operating system. What we did here was chapter by chapter. Okay? So some of the chapters we can easily recognize from this. Like processes was one chapter, threading was one chapter, paging, segmentation. This all came as a chapter T. Once you do that chapter, you solve some exercises, you go on to the next chapter. Now it's not the case. They will ask you a question which can actually span across all these things. So you think what they are talking about, what things apply from here, and then use that knowledge. So today I am not going to show you any slides because we don't have that much time first of all. Because it will be too much overwhelming for you. Just keep on showing slides till you are eligible. What I will try to do today is maybe reach something you missed out in the lectures is try to combine this everything into one small chapter. Take everything, just compress it, and the most important thing, the nutrients of all of these things. And it's like one capsule, and it will refresh. Hopefully it will refresh all of the concepts, and then you can read all of them. If you have any questions also after this, you can talk to me and get your answers. Starting with the first thing, you see the computers and using the computers, right? So can anybody tell me when you switch on the computer, when you press the button, what exactly happens? One basic question. Where is this boot letter residing? That's the meaning. Let me start throwing some terms for you. If any term is not known to you, you can ask. So you will know bias. It's something which is like a read-only learning sitting inside the computer. It is protected by the property that you cannot utilize. And this is programmed to know something which is talking about is boot loader. Bias are all the basic configuration, you know how much this processor, which memory, how much is the RAM and everything, where is the disk, which is the primary disk, which is the secondary disk and so on. Then, next. So boot loader by the way is a program. Right? It's not a location. By definition, it is a boot loader. So it is going to load something. Which is the boot. So this will load something. So what will it load? Operating system. Where will it find the operating system?
Starting address at MBR, master boot record.
Right. So the one thing I have to do, master boot record. Every hard disk has one identified space, which is a very special location on the hard disk, which is the master boot record. And this is where the whole initial code of the operating system is. If this gets corrupted, what happens? You cannot run an operating system. Because if this gets corrupted, the first thing cannot even start. without compromising each other. Right? So once you have partition in your operating system, then you get a choice whether you want to load Windows or Linux. You select an operating system. Depending upon your selection, you will jump. Okay, let's say I select Linux. So it goes to the Linux operating system code initially. What is the first thing that happens in Linux?
Memory devices and file system is ready to load or not, checking their correctness.
So, abstract it out. What is the first code that is loaded inside in the memory? Right? So, this is your PC. This is the hard disk. Hard disk, right? This is your processor. This is your RAM. And then you can have multiple items. Right? Keyboard, mouse, monitor, everything. What happens when Linux gets loaded? What is the code? What is the name of that code? Kernel. Every operating system is an identified piece of code from the operating system which is called kernel. Right? Can anybody define me what a kernel is? Right. So it's typically a privileged operations. So it's a privileged set of operations which are combined together in the operating system and it's all kernel. It stays in the hard disk and that first gets loaded inside the RAM. So the processor will take that code or whichever way you want to put it in the RAM. Now the processor can begin. So why do you take code from here to here? Anybody knows? These are very simple questions. These questions must have started out when you read about computers and so on. Why do you take code from here to here? Faster. Okay, so RAM is, the latency is faster. So once you put the kernel there, what will kernel do? There you see. Right. All these devices have something called a device RAM. Your monitor has a device RAM, your sound card, your network, Wi-Fi, Bluetooth, everything. Okay. So for driving all these devices, there is a special code which is called the device RAM. So once the kernel is there, you know what is the basic code of the kernel? What the kernel has to do?
System calls.
We are getting there. But what is something that kernel has to do?
Even in the hardware and software.
Even before we go into the hardware software business. So what is the basic computer? If I take this out, is it a computer? It's still a computer. If I take this out, is it a computer? It is processor, right? So the primary thing or the central thing of a computer is the processor. Right? So by definition, what is the most important thing that a computer should do is run a process. Like your ATM machine is also a computer, doesn't have a hard disk, maybe it has some RAM, but what it has is the processor and it can run a process. Right? So when you load an operating system, what is that you need to have is some way to start the process. And so there is a very basic process that they start, which is with process ID 0. Most basic or the grandfather process. Right? This is process and is even it's a init process. So it starts on its own. Right? It's like a dog. There is nobody before on the earth. First thing starts by itself, doesn't have a parent, right? Doesn't have parent, it starts by its own. Right? So that's why it's a zero process. After that, you can have any number of processes. And how do you create process? You spawn, right? And the system code is this is most operation that creates the whole operating system afterwards. It's the whole operation. Because 0 is there, it's building, it started on its own. After that, you execute code. What happens after code? Okay, child process. So this is process 0. Before it, it's a 1. Right? What are the properties of this process and this process? I'll use code. Then you can then answer this question. What exactly happens with the code? So there is a big relationship. It's like we have relationships with parents. Okay, so there's a big relationship here. And how is inheritance and inheritance and so on going on through this? It's now a family tree. Everything will go as a family. So what does parent give to the child?
Parent is the child person. Parent can give the child.
Parent
Can give the child person.
can take.
Give the child.
No. Let's talk about it. There's a lot of time to kill. Right? At the initial birth, what happens? What does parent give to the child? Money?
Sharing the resources.
Remember resources, very basic than that. Can you differentiate between parent and child after the child is born? Idea is different, right? But other than that, cannot. Right? Other than that, there is no differentiation. What happens in your experiment? It's like coming to the genes, duplicate the genes, something similar happens. Parent will give all the sources, everything, all the variables, everything. Right? So it's just a duplicate. You can now see why this thing is so fast. If you have to change the code, change the variables and everything, it would have taken or consumed a lot of time. And the computer will take a lot of time to do. The way this is done, it's a very smart thing. It's a simple thing but very smart thing to do. Is that you just create the copy of it. So child gets everything, doesn't have to work hard for anything. Right? Memory copy is very easy. Just copy bit by bit. It's like a reflection. After that, child gets everything. You can run any code that parent is running. Right? Other than the parent ID, you really cannot differentiate between parent and child. They are exactly the same copy of each other. Now, what is the point of duplicating? Right? Now we have a problem. If the child can do exactly the same thing as parent, why would parent create a child? The question is, if the parent and child are exactly similar, I can just use the parent to do everything. Why do I need a child? Right, so that is one utility. And if you want to do multiple things at the same time, using the same code you can do it. But this is not the average case. The average case is different. What will you do in the average case? And how do you do that? Right, so you basically reflash this, right? You reflash in the sense you wipe out its memory, change its code. Right? So for example, the init code that is running here, right? In the Linux, and then what you want to do is the shell, or you want a terminal, or you want SSH server, and so on. Right? So if you want these different utilities or different code to run, you will wipe out this memory and put a different memory and variables in it. So now what will happen is, now your computer is becoming powerful. You can not only run its unit, you can run your SSH server. You can create a terminal. You can load device drivers, right? So it is running different pieces of code. And this is how the tree will start doing. So for example, if I connect to SSH now, I can have a shell. What is the shell? But more specifically, what is it doing? Shell.
It goes to the network device.
Visually, how do you see the shell? It's a command line interpreter, right? you want to do something with the computer. You see, you type something, you execute something, you immediately get back instructions. As computers are becoming more and more powerful, they can become more and more interactive. In old days, the computer was not powerful enough, doesn't have active CPU cycles, so it wasn't interactive. With this shape, it has now become interactive. So any examples of shell in real life, do you know? What kind of shell can you see? Crash? These are different shells, and this will change the commands that you can execute, will change the way you see the computer and so on. So this is what is happening. Now let's fit all these things together. You switch on the computer. First thing, the BIOS gets loaded. BIOS knows where the master duplicate all this. You go there. If there is only one operating system, you load the master duplicate of the RAM, execute the operating system. If there is something called a graph, where it has multiple operating systems, and this is also partitioned accordingly. So you will get a menu saying which operating system you want to execute. Depending on what is your selection, select one. Which Windows Linux, same thing. You will load the kernel, the basic core operating system inside the RAM. You start execute. By execute, we need the first process is created. This is process ID 0. Okay. So this is loaded inside the memory. Once this is loaded, use 4. You create multiple processes by way of a system called for 4. And then this can keep happening. Right? So this can go 2, 4, 2 can go 3 and 4. Initially after every 4, you basically have a duplication of code. But if you want to execute some new code, you change it by using an execute command. Need a new code. So for example, this is your shell. Right? You see a command prompt. You type ls. You say enter. What happens after this? List of the files. But in terms of this, can you tell me what are the steps really happening behind? The operating system, what exactly is happening? So this is, let's say, the shell process. When you say ls and enter, it gets the code of ls, right? And it will force the new process, and then it will do exec b and put that code of ls here, right? And it will execute the new process ID 3. So running this 3 will actually load the code of ls, which means show me all the listings. To show the listings, we do exit, and when it finishes, we give back the control. So the parent is waiting. Because when you press ls, you don't see the command prompt till ls is finished. So that means the parent is waiting for the child to do something. When the child finishes, it signals it to the parent. Now parent goes, so the output is displayed and the shell, which is process ID 2, take back the hand. And you can again be ready for accepting the code. So this is the first thing that operating system once it gets loaded end-to-end runs. Any questions on this part? Till this part.
And what about to clearly understand the motivation behind doing why do we need a child processor?
You cannot load the whole operating system into it. You don't, first of all, let's say I don't have Wi-Fi. Why do I load the code of Wi-Fi? So you basically load something which is basic. And depending upon what is your next need, you create a process for that user. And you create a multiple process because you want to separate out the concerns. This has different memory, this has got its own memory, so they don't interfere with each other. They can work as say parallel. That is the reason of having to create a new process.
But both the child and the parent process will have the same the data items and the variable.
Right. So you can stay with it. If you let's say the HTTP server creates multiple threads, right, or multiple processes in the old days, everybody wants to do the same thing, which is the web server. In our case, you see this is shell and this is ls, which is different. So this child will have a different code than this parent. And that's why you use exit b. Then how about why you need the concept of code, what exactly happens when you do code. So I have a very simple thing to do. It's execute something in a meeting, but life as it is not so easy. Right? You do something simple, there's something else executing problems. And this is what the whole engineering is. When we are given a problem, try to find a simple solution as possible, but then with simplicity there are some always complications. And what is the complication of having multiple processes?
Allocation of resources.
Allocation of resources, that is one, but yeah, so let's say if I have infinite resources, I'm not worried about memory, hard
Which
disk.
process gives the which result? Which result is come from the which process?
That is also fine because everybody has a process ID. So in a world where we have infinite resources, still there is an issue if I create multiple processes. That is also true. So how do we schedule? That is one problem. Let's schedule it. Everybody wants the processor, right? When I say infinite resources, we don't have still infinite processor, right? So everybody wants the processor, so we have to schedule something. What is the second thing? Once you schedule, what will happen after the processor? Concurrency, right? So what happens is, even if there are infinite resources, as we know, when you give a chocolate to a kid or two kids, they will still fight for the same chocolate, right? The same thing happens with the processing. There are some special things in the memory which are very important. One is the time, like the global time or the clock time of the processor, which is what is needed by everybody, right? Or if there is a Wi-Fi card and there is data coming in, everybody wants to look at the data. So what happens is, have to worry about concurrency. So what if I don't worry about concurrency, what will happen? If I just create an operating system that is ignorant of concurrency, what will happen? Right. So typical example I give is of the clock. Right? There are two processes and there is the clock. Let's see what we get the clock. Let's take a simple example. X equal to 9. There are two processes P1, P2, who can read and write the same variable X.
But they would have different formulas of X.
So in this case, it's a global value. Something which is global. For example, of global thing is the clock. Can you give me a scenario? Or you have to think, come up with a scenario where if I don't have concurrency control, something bad will happen. Let's say this is one solution. And they unlock. and lock.
Suppose other process locks.
Right? So, like, there should be sequence of these two operations and so on. We can have directly a lock. But even this focus on the lock, I want to implement this on a Pentium processor in C language. How will I implement it? It's a lock operation.
The variable is not in ability to be written by any other process. So maybe that is there for a function. So it is like a local variable for a function.
Right? So it's all coming to the variable, right? So x is a variable. To access x, I have a lock function. So lock will also have its own variable. So I'm just creating variables. If I keep on creating variables, I can run into the same problem again. Of two processes stepping on each other's toes for the same variable. So I haven't really solved the problem here. Is this point clear? No, okay. So what I'm saying is, x is a variable. To safeguard x, I create a function which will have its own variables, and now I have to safeguard those variables. So it's chicken and egg now. What am I doing? I'm just creating more variables. I have to safeguard those variables. To safeguard them, I create one more variable. Again, I have to safeguard. I mean, I haven't solved the problem. So I have to solve this problem. So what do? Somewhere, if you know the recursive algorithms, right? You can call the same function through again and again recursively, but somewhere you have to stop. And say, I'm not going to call this function again recursively, I just return a value. I hope everybody knows recursive functions, right? So the same thing applies here also. It's all mathematical. I create lock, but then I should not create a new problem of variable, of locking and unlocking. So that's where we call something as atomic. So now we have something called an atomic function. So it's like the end of the recursive functions. They call it recursively again and again and again. At some point you say, okay, stop. You directly return a value. Same thing, atomic. So this lock function is atomic. What is atomic function? Right. So when you execute this function, you cannot, or no one cannot preempt this function. So now you just kill the problem of global variable. Right? Because by definition, if you say that when I access this variable, nobody can step me out or throw me out, that means I don't have the problem of concurrency. Which means that everything stops. So the buck stops at this stage. He's not going to forward this problem to somebody else. He will solve the problem. Now, I'm taking an embedded system course. So, actually now I'm going one level down. I talk about C and language and Linux and Linux and Windows. I'm skipping one step below abstract layer. And I actually go to the processor. How do I implement an atomic function on the processor? Because finally it's the Pentium processor, ARM processor, whichever processor I'm using, that has to do something, right? So I translated my C, or let's say my Java, to C. From C I have to translate it to assembly language, right? But somewhere, assembly language has to actually talk to the hardware. And what does exactly hardware do when I execute the atomic function? And this is where the whole business of system calls and so on comes. So on the real processor, by the processor, what do I do to make something atomic? Using light to ensure nothing else don't create right. So how do we do that? So this is my processor. Have you seen the processor? Actually see the processor? How has all these pins like this. So what is happening in the processor, like whatever language you are writing, C, Java, U, whatever it is, finally it's coming to the voltage. Right? It's a DC voltage, 1 volt, 0 volt, 2 volt. Everything is 1 and 0, which means everything is positive. 5 volts or this is 0 volts. Now if I want to execute something on this processor, I execute it in this pins. And if the new process wants to jump in, there is a pin, which you can say it's an interrupt. Right? So what do I mean if I want to say process P1 is running and I want to execute process P2 by preempting it, is I create an interrupt to the processor. Right? So the meaning of the word in English, interrupt, means you stop somebody in between and you ask him to do something else. Right. So basically what it means is you need to mask this or disable this pin on the processor. Right. So finally atomic function is what it is doing is it is disabling a pin on the processor for some time. It does the business of lock. After that it enables it. Right. And so that the processor or the process can be interrupted. Right. So the way you construct an atomic function by enabling and disabling the pin. And this is how it is finally done. And this is the solved problem. Yes. You don't need to solve it anymore. You can have atomic functions and then on top of that you can have these global variables without the problem of numbers. So any questions on this part? Atomic system. So log and unlog is one way to do this and typically used in the data analysis. In the operating system, what are other functions or data variables or structures? You have something called semaphore, monitor. What else? Okay, let's just go through semaphore and monitors. What is the semaphore? It can be binary, it can be counting also. So it's a variable. So you define a variable, a special variable inside the operating system is called semaphore, and there are two operations possible on that variable. What are those operations? Here, wait and signal. What is wait and what is signal? Right. So wait means whenever you want to access this variable, you become polite and then go and wait if somebody else is already using that variable. If nobody is using the variable, you immediately can execute something on that. So that is wait operation. And signal is very easy. Signal means when you are finished with using variable x or the semaphore variable, you just send a signal to other one and the operating system that I am okay, I am done. Somebody else can use it. And this whole thing is an atomic function at the bottom. So if I want to share a file, I can create a very small variable of semaphore say x. Right? And then lock and unlock the file by using x. If anybody wants to access the file, it will first look at x and then access it. So what could be a bad thing that can happen? A malicious process, what can we do? In case of file. Right. So one thing you can do is just ignore x. Ignore semaphore. And you can directly jump and read the file or write the file and then create issues. The operating system then has to have a mechanism to see whether the file is locked and unlocked and so on, and then these will be released. What is the difference between semaphore and monitor? If you have semaphore, why do we need monitors? Anybody remembers what monitor is? There is something in the word monitor itself which will help you to remember what exactly the monitor is doing. Actually, it is monitoring something which is more proactive. Semaphore is reactive, it is just sitting there and it expects you to give you all the information. Monitor means It is actively looking for things. Right? So what happens is if you signal something in semaphore, the other process has to still do wait and find out what's happening for the variable x. In monitor, this is more efficient. So if you do a signal in the monitor, all the other processes which are waiting will automatically get a signal. Okay, now you can proceed. So the core is the same thing, but this is more efficient because it proactively tells processes when to go ahead and use the variable.
So what's the explanation? I didn't get it.
The difference between two. So semaphore is wait and signal, right? When you do a wait operation, the process, let's say somebody is using the variable, has to wait. And then when somebody signals, the wait thing is still blocked. So the process is blocked. In monitor, what will happen is you are not blocked. You just execute the wait operation, you see the variable is not available, you just go get something in return saying you cannot execute or you cannot use X, but you can do something else. The process will do something else. When somebody do a signal, this process will actually get an interrupt. So okay, now wake up and your X is ready. So if you want, you can use X and proceed. So this is how the process can receive these messages or signals in terms of quantities. So both of them can be prone to malicious things. So the difference is this is more efficient. So we take the operating system, we use monitor. Semaphore was the first concept which to solve the problem, and now it has come to the monitor. Yeah, just to make it efficient. It's an efficiency issue. Right. So lock function is atomic, but you still have to do something to make it atomic. Right? So I said this is atomic function. Okay, but the processor say I don't understand what atomicity is. Pentium processor doesn't have something which is called atomic. For it, atomic means we have to then actually write assembly code which will disable the interrupt and enable it. So log will have some code 1 0 0 0 0 0 1 1 0, whatever the assembly code, right? So basically, the first thing you will do is disable, and then here it will do. And in between it can do whatever you want. Yes. 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 So you don't need to rewrite, right? Just like you have a function call, and you can call it for multiple locations. It's the same. The operating system provides you. Another thing is only operating system can provide you with this because it's privileged. In some memory locations, processes cannot be available. Cannot even check the read or write values. The operating system can do it. That's why, for example, this is a very powerful operation. If I want to disable the interrupt, I can actually take the whole control of the PC and make it act. And you don't want to give this capability to any processes, like Johnny or any XYZ process. Right? You just want operating system to do this. Right? Disabling and enabling interrupts. Right? So that's why it's within the operating system. So scaling is, I'm not going to go in detail about scaling because there are multiple algorithms and this is not the time to explain to the algorithms. Right? But basically what it means is, when I have a bunch of processes, P1 to Pn, operating system now has to decide which one to select first. And you all must be doing some examples of algorithms for scaling. Round robin is when what happens is you select one process, then second, then third, fourth, go to Pn, and come back to P1. It has its plus and minus points which you can read in the way. What is the other one? First come first. So what happens is, when a process comes, the operating system will take that one first, will execute it completely, finish it, and take the second. Again, it has what is the disadvantage of this?
Start.
Yes, so there are concepts of average waiting time and so on, which you can look at. What is the other one? Shortest of first. Shortest of first. What is shortest of first? So the idea is the long process, as it is, the person is done. Okay? And the person is writing a very short, small process, expected to get the work finished very quickly. So what you do is you do the shortest process first, because anyway the person with the long process is ready to wait for a long time. So that is shortest of first. What is the other one? So these are basic scheduling algorithms. In reality, we don't use any of these as it is. What happens in reality?
There are two types of scheduling. We combine different scheduling algorithms.
Right. So in any scheduling or any real operating system, what happens is it's a multi-level. It's an hierarchy. So what you do is you basically so you have these priorities, I can see. By the way, there is one more algorithm which is priority. So this is priority 0, priority 1, priority 2, and so on. Right? So you first of all take all the processes, divide them in terms of priority. Because operating system has some priority, right? It's the most important thing it has to run. You cannot say, okay, operating system process cannot run. Because for example, it has to increase the time level of the computer. It has to change something in the EDC packet. So it has to run, cannot wait. So it waits priority 0, then priority 1, and so on. So once you take all the process, divide them among different priorities. Within each one of these, you can then take shortest of first come, first serve, or whichever, right? So you have multiple levels. First thing is the priority. Second thing is something like this, right? And then on top of that, you can also do something which is long term. Okay? You can go through these queues one at a time. Another thing in Linux, what is done is some process schedule. For any process when it comes, get scheduled somewhere here at the top. If I start my process, it always at the top. It takes some time value, time slice of the processor, executes, if it finishes, it's very nice. And so I take some credits. Like you take the deal. And if I take too much time, I don't finish, I get penalized. What is my penalty? Next time, I start my process at the level 1 with. If I still don't finish my job, I go one level down and so on. And yet I will come at the bottom here. Actually, I write in Linux a very lengthy process. Initially it will be very fast. Then it will delay. Right? So it will become slow. So this is what is done in Linux. The real life operating system.
Possible to implement SGF first is that it's required before commission job and we should know the time how much time it will take to run. But isn't it possible to know before the completion of how much time it will take?
Right, so what can be the solution? That's a good question. So in shortest job first you really don't know what will happen to the process. Just like you're buying stock in the share market, a new company comes up and there's a startup, it goes public, IPO. You have, what do? You look at the stock market, a new company comes up, what do you do? You show I start a new company. What is the cost of the share? Some face value, you start with 10 rupees or 100 rupees. Right? You sell the share, there will be long-term results. Afterwards, after 1 month, people will see the performance of the company. And then, okay, now they will say this is not a value of 100, it has actually value of 500. Okay, because it is going to give me dividends, it is progressing very nicely. So over the time you learn. Same thing happens in the process, the operating system. When somebody comes, you just give you some face value. Then you are nice. The best thing to do is say, okay, you get the highest priority. But if you don't finish with the highest priority, you get low. If you don't know. So you can claim I am the shortest job today. Nobody is shorter than you, right? You execute operating system will figure it out. You are not the shortest one. You are taking too much time, right? And it will then keep you in the back. You can just lie once at the beginning. Later on you cannot. It's just a small thing at the beginning, but later on you get everything. It's a learning process.
But sometimes there are processes which takes longer time than some certain jobs short term. How to always decide like how many times.
Correct. So over the period of time you can do a weighted average. Okay? So first time you execute it, you take 10 seconds. Next time you take 8 seconds. Next time 10 seconds, 12 seconds. You can say on an average it is taking this much time, which is average of these 4 hours. Right? And then say, okay, on an average this takes this much time. As you keep on executing, the average will become more and more accurate. So this is intelligence. We have talked about critical.
So with time priority will increase or
questions?
So with time priority will increase or decrease?
Sorry?
With time priority will increase or decrease because aging.
Right, so it depends upon how you perform or how the process performs. The process is very fast every time. It is time slice. It will improve. If it is not utilized, so for example, the student is always delaying the assignments. Over the period of time, I will say, okay, this student is not good. I am not going to give you any more distinction. But if a student is always submitting on time, so he will create a reputation that he is a good student. So I can be lenient with this student.
Aging is like.
For aging is different thing. This is actually I am looking at its performance. Aging is one way to do that. It is binary. Aging means you spend 10 days in here to get some value. So this is one metric which is binary. What I am doing is more than binary. I actually judge a process, not just by its age, but by its performance.
The concept you just explained is different processes have different timing and have different inputs. So for that, the dynamic is going to be established.
Can you explain me what is dynamic state?
So the dynamic is like since at what time the process is made, so according to the assignment which should be ordered. If you have at particular time assigned the same as the process taking longer like 10 minutes.
This is dynamic. Static as it goes to be slightly level changes. This is dynamic.
Because of this reason, we consider animation is more efficient.
So static will not be there in reality. Even when we look at things, it's never static. It's not like we fix something as a schedule and then we change it. Everything is dynamic, the computer has to be dynamic. Because there are new processes, new workload, everything is happening, new users. Has to change every time according to the use of the user and according to the level. So in reality, you will have always find everything like that. What is? Aging what means is just that if you spend too much time and you get some value as a function of your existence, that you can define. Typically in the operating system, there will not be much value given to the aging. Some operating system you can generate an operating system and create your own operating system which value age. Typically you don't really consider the age of the process. So the priority, how it is performing, what is the need of the user and so on. Just by aging, you really don't know. You can change it. Some operating system if some process is taking too much time and it just increase this value. That is what aging is. So critical section. Critical section is where you access the global game. What we discussed about components. So that was critical section, not critical process. So section of the code which accesses the shared variable between all the 5, 10 minutes, 10 minutes, and then what is the difference between a thread and a process?
Threads share the same memory.
Threads do share something, processes don't. So what is that the process share and thread does not share? So what does the thread share? If I have two any process comes with these things. It has its code, it has a stack for what is a stack? It's a data structure. What is a stack? It is something like, forget it, like it, forget it, like it. But why is a stack? So what are the operations on a stack? Function call. Right? So what is the property of function call? Right? If you look at the stack, it's like this. Last in, first out. Right? Where do you need this concept for a code?
Instruction point. Memory address of the
Function calls. So you need a stack. So it's not the single theory, right? It's really used in the computer science. A stack is used whenever you make a function call. If I call a function f in some variables, right, I come to this execution. There is some state machine learning. So I have some battery in the variables. What I do is before I call this function, I push all my states, all my variables onto the stack. I give control to the function. So now control to the function will execute something. And then when I finish it, I should again get back the same values, right, of this. And the way it is done is through the stack. After I do a return with the function, this is something. If you look at the code, it will have a return string. So after you do return, you take out those values from the stack, push them to the processor, and then you keep executing the returns. So this is stack. What is it? It's dynamically allotted. So if you are using a C program, allocate memory. So there is a big chunk of memory that is given to the process, and it can keep allocating, right? And you can free. And then data is the standard local variables, X, Y, Z, and they go inside the register most of the time. So this is a process. What is a thread now? So I show you a process, and you need to explain me what is a thread. So code is not there. Code is what? Separate or same? So either it could be separate between the threads or different. Code will be the same. Stack. Why it will be different? Every thread has its flow of control, right? So if I push something on this, I shouldn't pop out something from here. Because otherwise the control of execution gets messed up. So this is different. Keep same data different. So you can create this one variable as you did. So basically thread is, so why do we need a thread? If we have a process, why create a thread? It's a lightweight thing. For every process you see there is so much information